Hello everyone. Today in this video we are going to understand advanced path manipulation of BGP. Guys, this video is going to be very useful, very helpful for you guys if you are a network engineer, if you are working in the industry, or if you are planning to work in the networking field, or if you want to planning to attend the interview of network engineer, because interviewer is also asking lots of questions from BGP. So this video will cover path manipulation, advanced path manipulation, as well as we are going to cover some advanced topics of BGP as well in this video. But as you know, to understand the path manipulation in BGP, first you have to understand the best path selection in BGP. And as you know guys, for best path selection, BGP uses attribute, right? There are some attribute. On the basis of that, BGP router is going to find best path. So first of all, let me discuss about that attribute in the series like router is going to use for the best path selection. So without wasting our time, let's begin the session. First of all, let me tell you about attribute. So guys, first attribute is next hop. First attribute is next hop. Next hop means, let's say I have one router and one router is getting same network information from two routers, from two others neighbor router. So it is going to check the next hop IP address, that the next hop IP address is reachable from both neighbor is not, right? If both neighbor next hop IP address is reachable, then only it is going to check next hop next attribute. Let's say, let me make you understand with one example. Here I have router number 1, and this router is connected with one another router R2, and here we have R3. Done. And the router 2 have received one prefix from their neighbor. Prefix is 10.1.1.0/24, and router 3 have also received same prefix from their neighbor 10.1.1.0/24. Any AS number I am running over here, that is not my concern now. Let's say between router 1 and router 2 I am running 12 network. So here IP address is 12.1 and here IP address is 12.2. So when router 2 is advertising this prefix to router number 1, its next hop IP address is 12.2. So 10.1.1.0/24, and router will receive this network information with next hop IP address what, 12.2. And let's say router 3 is advertising this network with, here I am running IP 13.1 and here I am running IP 30.2 or 3. And but router 3 is not updating their next hop IP address, and it is advertising 10.1.1.0/24 with next hop IP address, let's say 24.1. So as you know, 24.1 is not reachable from router number 1. So via router number 2, this path will become best, right? For this network, router will install path via router number 2, because one next hop IP address is reachable and one next hop IP address is not reachable. Okay, so first attribute is your next hop IP address. Next hop should be reachable. Okay, let's say both next hop IP address is reachable, then router is going to check what? Then router is going to check wait value. Wait. And always keep in mind, BGP not carry wait information in the update message. BGP never carry up wait value in the update message, but for self-advertised prefixes, for self-advertised prefixes, wait value is 32768. This is for self-advertised. For receive prefix, wait value will be always 0. We will use wait value for the path manipulation, but always keep in mind BGP does not carry wait information in the update. Again, if wait value is also same from both neighbor, from two side, then it is going to check third attribute, and third attribute is local preference. Local preference. In short, we said LP. In short, we said LP. Okay, and always keep in mind routers always carry local preference value for their IBGP neighbor only, for their IBGP neighbor, for IBGP neighbor only. Okay, for eBGP neighbors, router is not going to carry LP value. Done. So if local preference value is also same, then router is going to check fourth attribute, and fourth attribute is AS path. AS path. AS path means, as you know, whenever BGP share a prefix to their eBGP neighbor, it always include their AS number in the update. But whenever BGP share prefix to their IBGP neighbor, it not include their own AS number in the update message. And lower AS value is preferable. Let's say here I have again router 1, router 2 and router number 3. Let's say router 1 is getting same network, or let's say X network information. X network information from router 2 also and from router number 3 also. Here AS path in the update is 100 and 200. And here let's say AS path in the update is only 100. So it will, it will prefer which path? This path as a best path via router number 3, because here router is getting least number of ES. Here router is getting more number of ES. So less number of ES is always preferable. Okay. So always keep in mind the third attribute is ES path, and ES path is used to find the best path, used to find the best path on the basis of lower ES number. Done. Total number of ES. Fine. Next attribute is after ES, it is going to check origin code. Origin code. And we have three types of origin code, guys, but nowadays we are using only two origin code. First one is I, second one is E, and third one is question mark, that is incomplete. I means whenever you will advertise a network in BGP through network command, we have two options to advertise network in BGP. If I will show you, so let me take access of any routers. Here let's say just I am creating one loopback interface, loopback 100. I am creating loopback 100 so that I have already some loopback, so I don't want to take impact on those configurations. So that's why I am configuring loopback 100 here. Let's say IP address is 100.1.1.1 and 255.255.255.0. Now again I have two options to advertise this network in BGP. One is router BGP 500, and here we can say network 100.1.1.0, mask is 255.255.255.255.0. So if you will advertise a network through network command, then origin code will be I. So this one is nothing but your advertised network through network command. Done. E is your nothing but eBGP. Nowadays we are not using this protocol, so this attribute also we are not using actually, so we can leave this. We are using only two types of origin code attribute nowadays. First one is I, and second one is question mark, and question mark is nothing but your incomplete. So incomplete means, guys, whenever you will advertise a network through redistribution, you have one more option to advertise prefixes in BGP, that is redistribution. Okay, redistribution. So if I will advertise this network through redistribution by running command this redistribute, after that we can say connected, and yes, we can hit enter over here. So if I will advertise network through redistribution, then my origin code will be what? Then my origin code will be incomplete question mark. Now I am going to remove the loopback interface, loopback 100 from here, say no IP address, and say no IP interface loopback 100 also. Okay, I cannot run this command. See, now your next attribute is after origin code. Next attribute is origin code is your which number attribute? Origin code is number 6. It should be number 6. We have missed one attribute here. This one is number 6 attribute. Let me correct it. This one is 6. This one is 5. This one is local preference is 3, but between 3 and 5 we have one more attribute, that is number 4 attribute, that is self advertised attribute. Self advertised attribute. Self advertised means, let's say one of my neighbor is advertising one prefix 10.1.1.0/24, and same prefix I am also advertising, so I will prefer my self advertised prefix. I will not accept the prefix which my neighbor is advertising. So self advertised prefix is always more preferable than the receive prefix. Done. And now we have 7 types of attribute, that is 7th type of attribute, that is mad. And mad is metric, like in IBGP, as you know, all IBGP routing protocol like EAGRP, OSPF, or RIP, these routing protocols calculate their metric for the best path selection. Like same in BGP also we have one attribute called MAD, and MAD is nothing but the metric. It is metric. And BGP is not going to carry MAD information also in the update message. Now let me talk about the 6th attribute. Sixth attribute is external over internal. As you know, in BGP we have 2 types of neighbor, external and internal. If we are configuring BGP between same AS number, that is internal BGP. If we are configuring BGP between different AS, let's say I have 2 router R1, R2. Here I am running AS number 100. Here I am running AS number 100. So this one is my IBGP neighbor. And if here I have router 1, again router 2, and this time here I am running AS 100, and let's say here I am running AS 200. So this is nothing but eBGP. So always keep in mind, external is always preferred than internal. This one is more reliable, external. So let's say router 1 have one more neighbor here, router number 3, and here I am running as number what, 200. So here I am running one network X, here also I am running network X. So router 1 will get X network from both neighbor, from router number 3 also and from router number 1 also. Let's say both next hop is reachable, weight value in the both update is same, local preference value is also same, both are receive prefix, ES path is also same, origin code is also same, metric is also same, then it is going to check what, external over internal. And on the basis of this attribute number 8, it is going to select best path. So this path will become best path because here I am getting same prefix from my eBGP neighbor, and here I am getting same prefix from my IBGP neighbor. So external is always best over internal. Done. Now guys, next attribute is attribute number 9, and that is IGP cost to reach next hop. IGP cost to reach next hop. Okay, so if till here all attribute will match, then router is going to check what IGP cost, means IGP metric. As you know, all routing protocols have their own algorithm to calculate metric. So it is going to check that metric to reach the next hop IP address. Let's say again I have two router 2 and router 3 is my neighbor, and to reach router 2 cost is 5, and to reach neighbor 3 router 3 cost is 10. So lower cost is always best, right? So it is going to check this attribute, and till here if all attribute is same, then only we can perform load balancing in BGP as well. Okay, till here if all attributes are same, then only we can achieve load balancing, then we can perform load balancing. As you know, in BGP we can perform load balancing, but for load balancing the criteria is IGP cost to reach next hop, it should be same. Attribute till IGP cost to reach next hop should be same. Okay, for let's say IGP cost to reach next hop is also same, like in my scenario here, R1, R2 and R3. Cost to reach 12.2 and cost to reach 13.3.3 is, let's say, same. Then it is going to check the next attribute number 10, and that is oldest path. Oldest path. Like oldest path is best, like your old friend is always your best friend. Let's say two of your friend is asking for 500 money, so one is your new friend and one is your old friend. So to whom you will give 500 rupees? To your old friend, like, right? So like that, router R1, R2, R3. Let's say first router 1 have received X network from router number 2. So again, both network is advertising same network, X network, and let's say router 1 have received X network information first from router number 2. So it will make via router number 2 as best. So this is a concept of oldest path. Done. Okay, if router is receiving, and you know, oldest path is only for eBGP neighbor, this is not for iBGP neighbor, this is only for eBGP neighbor. Okay, not for iBGP neighbor. Then how to perform best path selection if IGP cost to reach next hop is same in case of iBGP neighbor? So we have 11 types of attribute, that is lower, neighbor router ID, and as you know, it cannot be same. Lower neighbor ID, router ID of a router is a unique, right? So here election will happen, right? Till here in case of iBGP, you know, best path selection will happen, and in case of iBGP till here best path selection will happen. But let's say in case we have router like this R1, R2, and we have two link here. So this time router neighbor ID is also same, right? This time neighbor router ID is also same. So if neighbor router ID is also same, then it is going to check the next attribute, that is lower neighbor IP address. Lower neighbor IP address, right? And as you know, IP address of two router cannot be a same. Done. So these are attribute which router is going to use for best path selection. Like guys, in my scenario, if I will make you understand with this topology, first of all let me make you familiar with this topology. Here you can see this is my private network, this is my private, let me increase the size of pane. This one is my private network, let's say network of PM networking dot in, or PM networking private limited. Here in my enterprises network I am running AS number 500. Okay, but you know, here we have BGP neighborship between router 1 to router 5 and router 1 to router 6 only. right? And in the same way I will configure later between neighborship between router 2 to router 5 also, and router 2 to router number 6 also. There is no any neighborship between router 1 to router number 3, or there is no any neighborship between router 3 to router number 5. And here also like this, there is no any neighborship between router 1 and router 4. But for the connectivity, as you know, between router 1 and router 5 we have multiple paths, right? I can reach via this path, 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 yes or no? So we have lots of path available between router 1 and router 2. That's why we are configuring these. We have configured BGP through loopback IP address. So my requirement is what? To configure BGP neighborship between 1.1.1 and 5.5.5. That 1.1.1 should be reachable with 5.5.5. So I am running IGP protocol like OSPF here for the reachability between 1.1.1 and 5.5.5. Through OSPF, all loopbacks are reachable with each other. Done. After that, I have two connectivity from two different ISP. One is Sprint US, here you can see, and on Sprint US we are running AS number 200, and we have one British Telecom, and here I am running AS number 100. I have one more private network in New York, that you can see New York router, and here I am running AS 1234. Done. So I want to receive these prefixes in my network. So how many paths I have to receive these prefixes? One through Sprint to US, one through British Telecom on router number 6, and one through British Telecom on router number 5. So this is my topology. Okay, so as I told you, here we have BGP neighborship, 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 and here we have BGP neighborship between router 1 and router 5, and here we have BGP neighborship between router 1 and router number 6. So here on router number 6, if I will talk, sorry, on router number 1, see, both neighbor router 5 and router 6 is my BGP neighbor, because here also I am running what? AS500, and router number 1 also I am running AS500. So here this is my BGP neighbor. But if I will talk about router 5, between router 5 and Sprint US, this is eBGP neighbor, because here I am running AS500, and on Sprint US I am running AS200. In the same way, between router 5 and router number 8 I am running eBGP. In the same way, between router 6 and router 8 I am running eBGP. Router 8 to New York router eBGP. Done. So router 5, if I will talk about the router 5, so router 5 will receive these prefixes from Sprint US also, from British Telecom also, right? And guys, live here now. Just think that router 1 will get these prefixes from two neighbor, from router number 5 also, and from router number 6 also. So first of all, you tell me which path is best for router 1 to reach in this network, via router 5 or via router number 6. So both are IBGP neighbor. First of all, it is going to check what? Next hop IP address. Let's say this is the network. This is the network which router 5 is also advertising to router 1, and router 6 is also advertising to router 1. Through connectivity is there through OSPF. So if you want to check connectivity, let me show you guys. So see, this is my router number 1 here. So IP route 5.5.5.5. Yes, this route is available in the routing table. Route for 5.5.5 is available in routing table. Non-Y OSPF distance is this one. Metric is what? 3. Metric is 3. So IP BGP. So see, router is receiving 192.168.20.0 or 10.0 from both neighbor, from 5.5.5 also and from 6.6.6 also. But best is via router number 5. Now question is why? Because first of all router is going to check what? Next hop. So ping 5.5.5.5. See this next hop is reachable, then 6.6.6.6. Both next hop is reachable, then it is going to check what? Weight value. So IP BGP. Weight value is what? Weight value is, for receive prefixes weight value is 0, you can see. For self advertised prefixes weight value is 32768. So these are advertised prefix and these are received prefix. So from both neighbor it is getting what? Weight value? 0 weight value, same. So this attribute tie. Now it is going to check what? Next attribute, that is local preference. And local preference is also, you can see, local preference value is 100 for IBGP neighbor. So both are IBGP neighbor, so that's why it have received prefixes from both neighbor with 100 local preference. Then it is going to check self advertised. So no, router is not advertising this prefix, router is receiving from neighbor. Then it is going to check what? AS path. So see AS path in both update, it is getting same AS number, AS 100 and 1234, AS 100 and AS 123. From both neighbor it is getting same number of AS as well. Then it is going to check origin code. So origin code is also, you can see, I, right? Means on New York router we have advertised this network through network command. Then it is going to check what? Metric, mat value. So mat is also 0, you can see. MAT value is, as I told you, that BGP not carry MAT value. So MAT is also 0. Then it is going to check external over internal. So both are internal neighbor. So there is no comparison of external over internal as well. Then it will check IGP cost to reach next hop. So IP route 5.5.5.5. What is IGP cost to reach next hop, guys? 3. What is the IGP cost to reach 6.6.6? 3. So IGP cost to reach next hop is also same. Then it is going to check what? It is going to check lower neighbor router ID, because in case of eBGP it is going to check oldest path, but in case of IBGP, both are IBGP neighbor, so it is going to check lower neighbor router ID. And as you know, router 5 have lower router ID than router 6. Yes or no? So that is the reason why router 1 have installed these all prefixes in their routing table via router number 5. Now see the first path manipulation. What I want, that router 1 should receive these prefixes from router number 6. This is my first requirement. So what we can do, we can manipulate the path with the help of first attribute, that is weight value, right? Weight value. Or if you want to use you want to manipulate the path with next hop IP address, that also you can do, right? That also you can achieve over here. But I am not going to perform path manipulation by using next hop IP address nowadays, or I don't think that anyone is doing path manipulation with next hop IP address. So I am going to use the weight value. So what I will do, see, now router 1 is getting 192 prefix from both neighbor with weight value what? 0. Now I am going to add some weight value on router number 6. I need to tell to router number 6 that whenever you will share any prefix to your neighbor 1.1.1.1, you should add weight value, let's say 10, right? Like this, we need to create one route map over here, route map on router number 6. So guys, let me show you. So see, router 1 is, so IP BGP. Router 1 is receiving these prefixes from both neighbor, from 5.5.5 also and from 6.6.6 also, but it is best via router number 5. Guys, we cannot apply weight value in the odd direction, so we will apply it on router number 1. First of all, I will match the network. First of all, what I will do, see, by default weight value is 0 for received prefix from IBGP neighbor. Done. Now what I am going to do, I am going to configure one access control list, let's say 10, and permit 192.168.0.0 wildcard mask 0.0.255.255, or without matching any address. If I will try to, let me do one thing here, say route map, and directly name is CCNA permit 10, right? If I am not matching anything, that means it will match all traffic. Here I am going to say set weight value is, let's say 100, and now I am going to apply it with neighbor router BGP 500 and neighbor 6.6.6.6. After that, route map, use route map CCNA with this neighbor in direction. Done. Now say clear IP BGP star soft in. So IP BGP. Now see, best is via router number 6. Yes or no? Because here you can see weight value is, if you will maximize it, here you can see weight value is what? 100, and here weight value from router number 5 is 0. Right? Weight from router number 6 is 100, weight from router number 6 is 0. Now if you want to verify everything, so you can run command show route map. Just this is my first path manipulation, that's why I am showing you route map as well. In the route map you can see I have not matched anything, so it will match all because I have created the route map with permit statement. And so run section BGP. I have applied this route map with neighbor 6.6.6 in direction. Okay guys, so this is the first path manipulation. Now router 1 have received these prefixes from router number 6. Now I am going to remove this route map, send router BGP 500 and no neighbor 6.6.6.6 route map CCNA and direction in. I have removed this configuration. Let me remove the route map as well. Route map CCNA permit 10. I am going to say no. And again I am going to clear IP BGP star soft in. And so IP BGP. Again it have installed path via router number 5. Because now from both sides you can see weight value is 0. Now I want to perform load balancing with the help of weight value only. Let's say what I want to forward traffic in these 3 network, these upper 3 network via router number 5, and in these, in these 3 upper network via router number 5, and in these 2 lower network via router number 6. So that also I can achieve with the help of weight value. So see, on router number 1, in this scenario actually we need to define the interesting traffic, yes or no. So summary address of these 3 network will be, summary address of these upper 3 network will be, guys, you can calculate the summary address. I am just telling you directly, I am not going to calculate it. Summary address will be 192.168.0.0/19. This will be the summary address of upper 3 address, and the summary address of lower 2 address will be 192.168. I think 32, yes, 32.0/19. This is the summary address. As you know, /19 means 255.255.224.0. Done. Now see, On router number 1, I am going to define the interesting traffic first. So let me take you on router number 1. Okay guys, here to for the classification, actually we have access list also and we have prefix list also. So either you can configure access control list or you can configure the prefix list. So let me use prefix list over here. That will be good. IP prefix list. And if you want to configure access control list, you can configure access control list also. IP prefix list, the name of prefix list is, let's say, wait, what name of prefix list is wait, and then you will define the statement. So a statement is permit. Just I am creating a prefix list for the classification of traffic. Here you will define the network. So network 192.168.0.0/19 and greater than equal to 24 and less than equal to 24. This is prefix list configuration. I am not going to discuss prefix list over here. Hope you already know these things. I have created one prefix list where I have assigned, I have classified this traffic. Done. Now I need to create one more prefix list, IP prefix list. And this time, let's say name of this prefix list is wait 1 and permit 192.168.32.0 and /19 and less than greater than equal to 24 and less than equal to 24. Done. I have created two access control prefix list. In that I have defined the network. Now I am going to use what? Route map. So say route map. After that, name of route map is, let's say, CCNA permit 10 and match IP address from list number from prefix list. Wait guys, 1 second. I don't need to use this prefix list as well. Suppose I will add wait value for this prefix list for these prefixes. So for these prefixes, best path will become via router number 6 or via router number 5, and for the rest path, best path is via router number 5. So here I am going to use only one prefix list, that is wait. Wait match IP address prefix list wait and hit enter. Done. After that, set wait value is 110. Let's say I have set 110 wait value for the traffic which is inside the prefix list wait, and in the prefix list wait you can see which network is there, 192.168.0.0/19. Done. Now guys, route map. Okay, route map is done. So actually you have defined one permit statement route map, so you need to create one more route map with otherwise all other traffic will deny. So let me create one more route map with name same CCNA and permit statement with higher sequence number. Now I am going to use this route map with BGP. So router BGP 500 and here neighbor is 6.6.6.6. For this neighbor use route map CCNA and in which direction? In direction. Now clear IP BGP star soft in. Okay. Now guys, if you will verify the BGP table, see, so IP BGP. In the BGP table for upper 3 network, you can see best is via router number 6. Yes or no? Because here local preference value is 110, here local preference value is 110, here local preference value is 110. For the lower 2 prefix we have not add any wait value. So best is via router number 5 on the basis of lower router ID. So for upper three prefixes, best path selection is happening on the basis of weight value, and for the lower two prefixes, best path selection is happening on the basis of lower neighbor router ID. Done. So now it is performing what? Load balancing. So if you will, first of all, let me ping 192.168.10.10.1, let's say. So I am not able to ping. Let me verify the New York router, that New York router have 10 prefixes or not, because my source IP address is now 12.1.1.1. It's that's why it's not pinging, or maybe 13.1.1.1. So IP BGP. So 10.1.1.0 network is there. Now I am going to ping from router number 1. I am going to use extended ping. Source IP address is 10.1.1.1. Now it should work. Still it's not working. So I need to verify it why it's not working. Here on New York router, just let me check the IP. So IP interface brief exclude unassign 192.168.10.1. It's fine on router number 1. So IP interface brief exclude unassign. Here also 10.1.1.1 is 1.1.1.1. Here it is 1.1.1.1. Right. So let me correct the IP address of loopback interface. Interface loopback 1 is 1.1.1, fine, but I am going to create one more loopback 10, let's say, and here IP address is 10.1.1.1 255.255.255.0. Loopbacks, okay, loopback 6 is already there with this IP address. So IP interface brief exclude unassign. Yes, loopback 6 is already there. Okay, so then it should work. So IP route BGP, so 192.1. Now I need to troubleshoot it, that why I am not able to ping. So in the routing table you can see 10.1.1.192.168.10.0 is there. I am pinging which IP address, let me verify. 192.168.10.1. okay, source is 10.1.1.1 and 10.1.1.1 is available in the New York router. So IP route BGP 10.1.1. is reachable via which router? Is reachable via router number 8. It's perfect. On router number 8 also, let me check the connectivity. Enable. So IP route BGP. So 192.168.1.0 is there via router number 668.1.1.8. okay, so router number 6, let me take you on router 6 here. So IP route BGP, it should be BGP control shift 6. okay, now on router number 6, so IP route BGP 192 is available via router number 1 directly, so it will forward traffic to router number 1, so it should work. Let me ping 8.8.8 from here. Ping 192.168.10.1. here again source IP address will be this one. Source IP address will be 68.1.1.1. that's why I am not able to ping, but what we can do, and end-to-end connectivity should be there. So IP route BGP. So 192 is also there. Let me do one thing, guys. From router number 1, I am going to ping the lower network. This is 40.1 via router number 5. Let me check it's working or not. So no, it's also not working. So just wait. In the routing table, route is available. So IP route BGP 192.168. All prefixes are there. Next hop IP address is 6.6.6. For these prefixes, it's 5.5.5. So it will forward traffic to 5.5.5. I am able to ping 5.5.5. So on router number 6, so IP route BGP. This network is available, and this network is also available via 68.1.1.8. So it will forward traffic to router number 8, and router number 8 should forward it to router number 9, and router number 9 should generate reply, but it's not happening like that. So what I am going to do, I am going to trace route 192.168.10.1, source is 10.1.1.1, numeric. Let me trace route. Not able to find the path. How it's possible? Path is available in the routing table. These are sometimes, problem of software. Control Shift 6. Okay, I am not able to ping. So what we can do, either we can troubleshoot it, ping 5.5.5.5, or I can show you directly the path manipulation, guys. 6.6.6.6. Yes, I am able to ping both neighbor, and both neighbor from router number 5 and router number 6. Can I ping? No, I cannot ping. So what I am going to do, I am going to advertise, let's say 5.5.5 in BGP to check, or 6.6.6 in BGP to check connectivity from here to New York router. So let me do one thing. Router BGP 500 and network 6.6.6.6, and before running this command I need to check the subnet mask of this interface as well. So do so interface loopback 1. Here subnet mask is what, 32. So I am going to advertise it with 32. Network 6.6.6.6 and mask is 255.255.255.255. So router number 8 will get 6.6.6 here. On router number 9. Okay, so 6.6.6 is there. Let me ping from router number 6 to 192.168.10.0, ping 192.168.10.1, and source is 6.6.6.6. Yes, from here I am able to ping. From here I am able to ping 192.168.10.1. Then why I am not able to ping from router number 1? Let me change the source once. Source is 2.1. Okay, I am not able to ping from here. I think this is problem of software, guys, because in the routing table see root is available. So IP root. So IP root BGP root is available for all networks, so it should forward 6.6.6, and from 6.6.6 I am able to ping that IP address. But you can see the path manipulation. These two networks are reachable via 5.5.5, and these three networks are reachable via 6.6.6.6. Done. Okay, let me give me some more time to troubleshoot it. Let me stop. It's still not working. What I am going to do now, I am going to remove the configuration because it's clear how we can achieve load balancing and path manipulation with the help of weight value. So IP route BGP, you can see, right? So route map. Okay, so in route map you can see I have created two route map with sequence number 10 and sequence number 20. In sequence number 20 I have not match anything, so it will match all. And in sequence number 10 I have match IP address from prefix list weight. And if you want to check the prefix list, so IP prefix list weight. So you can see in this prefix list I have matched this network. Done. Now I am going to remove everything, all configuration. No IP prefix list, name is weight, and say no. And no prefix list weight 1 as well. Say no route map CCNA as well. And a router BGP 500, and do so run section BGP. I need to remove one command from here also, this command. So let me copy it and say no, and let me paste it over here. Again, if you will clear IP BGP star soft in, you can see so IP BGP. In BGP table again all prefixes is best via router number 5. All prefixes is best via router number 5. Now I am going to use local preference, that is third attribute for the path manipulation. So see ST again router 5 is best path is via router number 5. So I want to make best path via router number 6. So on router number 6 directly what I am going to do, first of all here also I need to remove one command, that router BGP 500 and no network 6.6.6.6 mask is 255.255.255.255. I have removed this command, and here I am going to create what I am going to add what local preference values. Say route map and name is CCNA permit. Done. Okay, here I am going to say set local preference value what 110. By default on router number 1, see the local preference value is what? By default local preference value for IBGP neighbor receive prefixes is 100. From router number on router number 6 I am going to add 110. I will use this route map with BGP. So router BGP 500 and say neighbor 1.1.1.1 use route map whose name is CCNA and direction is out. I have applied this route map. Let me clear on BGP table. Clear IP BGP star soft in. Done. Now on router number 1 you can see so IP BGP. Best path is via router number 5. Okay, here also let me clear IP BGP star soft in and so IP BGP. Now best path is via router number 6 because of local preference value. Here local preference value is 110. Here local preference value is 100. So router 5 is advertising with default local preference value, but router 6 is advertising with higher local preference value. That's why router have installed all path via router number 6. So IP route BGP, you can see all prefixes are reachable via router number 6. Again, if you want to perform the load balancing, you can achieve load balancing as well. For that, to achieve load balancing, first of all, let me remove this configuration. Say router BGP 500, and here I am going to say no to this command. After that, no route map CCNA. Done. Do so route map. There is no any route map. Again, I will do what? I will match. I will create one prefix list to match upper 3 network, and here I will add some local preference value for the upper 3 prefix. And let's say what I want. Let's say I want that for upper 3 prefixes, router 1 should receive prefixes via router number 5, so it will forward traffic to router 5. And for the lower 2 prefixes, router 1 should receive prefixes via router number 6. So how we can achieve it? To achieve this task, let me take you on router number 5. On router number 5, what I am going to do, I am going to classify upper 3 network through prefix list. So IP prefix list, name is, let's say LP, means local preference, and here I am going to say permit 192.168.0.0/19 and greater than 24 and less than also 24. Done. After that, route map, and let's say CCNA permit 10 and match IP address from which list? From prefix list LP. Okay, and set local preference 110. And now on router number 1, before configuring it, if you want to verify again the all prefixes are reachable via router number 5 or not, so you can run clear IP BGP star soft in. So IP route BGP, now you can see all prefixes are reachable via router number 5. Now my task, I am performing task that these prefixes should be reachable via router number 5 and these two prefixes should be reachable via router number 6. So here I have created the route map on router number 5, and now I am going to apply that route map with BGP. So actually I have created it on, I think so, on router number 6. Okay, no problem. On router number 6, let's say for upper 3 prefixes I want to forward traffic via router number 6. So router BGP 500, and here we will say neighbor 1.1.1.1 and use route map with this neighbor whose name is CCNA, and direction will be what? Out. Clear IP BGP star soft in. See, now on router number 1, clear IP BGP star soft in, and so IP BGP. These upper 3 prefixes are reachable via router number 6, and for these 2 prefixes, okay, first of all, can anyone tell me why router 1 is not getting these 2 prefixes from router number 6? Because it should, sorry, in BGP table, so IP BGP. In BGP table you can see these prefixes. Router is not getting these 2 prefixes from router number 6. Okay, so actually here on router number 6 you have not defined the permit statement in route map with higher sequence number. So see, route map name is CCNA, and name is CCNA or something else. Yes, CCNA permit 20. Now router 1 will receive these prefixes from router number 2 also, from router number 6 also. Clear IP star soft in. clear IP BGP star soft in and show IP BGP. You can see now. Router is getting these two prefixes from router number 6 also, but best via router number 5. But now this router is selecting best path on the basis of lower neighbor router ID. But what I want that router should select best path via router number 5, but on the basis of what? Local preference value. So on router number 5, you will define the interesting traffic for the upper two traffic. Lower two traffic. So let me do that also. IP prefix list LP permit 192.168.32.0/19 and greater than equal to /19, greater than equal to 24 and less than equal to 24. Done. Route map CCNA and permit 10. Match IP address from prefix list LP and set local preference value at 110. Getting my point? After that, I am going to apply this route map with BGP. So router BGP 500 and neighbor 1.1.1.1 and use route map CCNA in which direction? In odd direction, right? Now on router number, and you need to configure one more statement in route map. Let me do that also. Route map CCNA permit sequence number 20. Done. Now on router number 1, you can see show IP BGP, clear IP BGP star soft in and show IP BGP. See, this prefix is best via router number 5 on the basis of what? Local preference value. Because for the lower two prefix, router number 6 is sending the default local preference value, but for the upper three value, router 5 is sending the default local preference value, right? For the upper three prefixes, router 6 is sending higher local preference value and router 5 is sending the default local preference value. But for the lower two prefixes, router 5 is sending the higher local preference value and router 6 is sending the default local preference value. Done, guys. So that's why show IP route in the routing table also. So IP route BGP, you can see these upper three prefixes are reachable via router number 6 and these two lower prefixes are reachable via router number 5. Done. So till now we had discussed the path manipulation by using local preference value and weight value. Now I am going to use the next attribute for the load balancing, for the path manipulation, and for the load balancing also you can say. Now guys, we are going to use attribute number 5 for path manipulation. Let's say AS path is used for outgoing traffic, right? For outbound traffic. Let's say, see these prefixes 10.1.1.0 to 10.1.5.0. Router number 9 or router number 8 British Telecom is receiving from two neighbor, from router number 6 also, from three neighbor actually, from router number 5 also and from router number 7 also. Yes or no? Yes, definitely it will receive from all their neighbor. But which one will be the best path? So both are their eBGP neighbor. Yes or no? Both neighbor are eBGP neighbor. So first it is going to check what? Next hop. If next hop is reachable, again it is going to check local preference value, weight value, then local preference value, then self-advertised, then AS path. So when router number 8 will receive these prefixes from router number 1, AS will be 500 only. When it will receive from router number 6, AS will be 500 only. When it will receive from router number 7, AS will be 500 and 200. So definitely this one is not best path, but out of these two path, here AS path is also tie. It is going to check origin code will be same because I have advertised this network through network command. Then it is going to check MAD. So MAD will be what? 0 from both side. From both neighbor, MAD will be 0. Then it is going to check external over internal. So both are external neighbor. Then it is going to check IGP cost to reach next hop. So next hop will be this one. Next hop will be this one. IGP cost to reach next hop will be also same. Then it is going to check what? For eBGP oldest path. So now router number 8 will select best path on the basis of oldest path. So let me check that router 1 is for router number 8 which path is best path. So let me take you on router number 8, and here so IP BGP, so IP route BGP directly. Let me run so IP route BGP. So 110.1.1. These prefixes are reachable via 68.1.1.6. That means via router number 6 it is best. See, till now we had discussed path manipulation for the traffic which my AS will traffic for the traffic which will exit from my AS number. Yes or no? Which will exit from my AS number, because we were performing the path manipulation for this traffic. So let's say if router 1 have received these prefixes via router number 5, via router number 5. So whenever router need to forward the traffic in this network, it will forward traffic to router number 5, then to router number 8. If you router 1 is receiving install this network via router number 6, so whenever router 1 need to forward traffic in this network, it will forward through router number 6. So actually we perform path manipulation for the traffic which will exit my AS, but now through AS path we are going to perform path manipulation for the traffic which will come in my AS, right? Like for this network, let's say if router 1 have installed this network via router number 6, so whenever New York router will send traffic in this network, router 8 will forward it to router number 6. Then it will forward it, and let's say I want that whenever traffic will enter in my AS, it should be entered via router number 5, because there are two exit point, there are two entry point or exit point in my AS. So now traffic is entering in my AS through router number 6, via router number 6, but I want to enter traffic in my AS from router number 5, let's say. For that, here you can add the local preference value, yes or no. Here you can manipulate the things, but this is ISP, you don't have access of these router, yes or no. Whatever thing you can configure only on your routers in your enterprises router. So what I am going to do, see, now router number 8 have installed these path via router number 6, right? What will happen if I will set AS path over here? It is sending AS number 500 only, and if I will prepend one more AS, that is, let's say AS 600. So now automatically best path selection will happen on router number 1 on the basis of AS path. Now best path selection is happening on the basis of oldest path, yes or no. So if let's say this one is my best path for router 1, router 8 is entering in my AS via router number 8, so I can prepend the AS over here. If router 8 is entering in my AS via router number 6 and I want to enter outside traffic in my AS via router number 5, then I will add AS number over here, AS prepend. So lower AS path is always preferred. Okay, so let me take you on router number 8, guys. Okay, so in the routing table you can see router 8 have installed all path via router number 6. Let me maximize it, and so IP BGP. See, router is getting these prefixes from all neighbor, right? From neighbor 67.1.1.7, this neighbor, from neighbor 7. But here you can see the AS path is 200 and as well as 500. It is receiving from router number 5 also with AS 500. It is receiving from router number 6 also with AS 500, right? So between router 5 and router number 6, it is not selecting best path on the basis of AS path because AS path is same. Now see what I am going to do. On router number 6, I will add some AS number with neighbor router 8. See on router number 6. Oh, wait. Control Shift 6. Okay, done. See now. Enable config T. Here also I am going to create the route map. Let me CCNA and permit. Here I am going to what happen? Specify. Okay, there are previous configurations. So say no route map CCNA, no IP prefix list, wait, and router BGP 500 and say so do so run section BGP no, and let me remove this entry, not this one, this one. Done. In the same way I need to remove configuration from router number 5 also. So let me take you on router number 5. No route map CCNA. After that no IP prefix list LP and a router BGP 500 and do so run section BGP. Say no and let me remove this command. Done guys. Okay. Now I am going to add prepend AS number on router number 6 for neighbor 8, router 8. So exit route map CCNA. Permit sequence number, let's say 10. And here we are going to set AS path prepend. And here I am going to add AS number, let's say 600, 700 and 800. Done. I am going to use this route map with neighbor router BGP 500 and neighbor 68.1.1.8 is the IP address of router 1. See, between router 6 and router 8 I am using IP 68.1.1.8. Done. After that here I am going to say use route map, name is CCNA and which direction, out direction, right? Clear IP BGP star soft in. Done. In the same way on router number 8 also I am going to clear the BGP table. Clear IP BGP star soft in. So IP route BGP. First of all, see these network are best via now router number 5. Now if you want to see the reason why it is best via router number 5, so IP BGP. See, because from router number 5 it is getting AS number 500 only, but from router number 6 it is getting AS number 500, and we have prepend 600, 700 and 800, right? So as I told you that lower AS number is best. So that's why via router number 5 it have installed as a best path. Okay. Now again, if you want to perform the load balancing, right? If you want to perform the load balancing for the traffic which will enter in your AS, we had discussed that the load balancing for the traffic which will exit my AS, which will go outside from my AS. Now if you want to perform the load balancing for the traffic which will enter in your AS, then what you will do? See, again you have to define the interesting traffic. Let's say for these upper three network, what I want, uh, for these three network, whenever traffic will come, it should come via router number 5, and for these two network, traffic should come via router number 6. Traffic should enter via router number 6. So that also we can achieve here. First of all, let me remove the configuration, guys. Here on router number 6, say router BGP 500, and I am going to say no, and no route map CCNA. Done. So till here, if everything is okay, please let me know in comment, guys. If you have any doubt, please let me know in comment. If everything is fine, then we can move further. So to achieve load balancing, let me take you on router number 5. First of all, what will be the summary address of these three upper network? Guys, let me make you understand the summarization of prefix as well once. See, I want to find the summary address of these three upper network. So I will check the change. Change is occurring in which field? So change is in third octet. So I will convert the value of third octet into binary. So binary of 1 will be 1. Then binary of 2. Binary of 3. Done. 2 4 6 8, 2 4 6 8. Now you need to find how many bit is common. So 1 2 3 4 5 6. 6 bits is common, and 16 bits is common in first octet and second octet. So 16 plus 6, 22. 22 bits is common, and here you will perform the AND operation. So all value will be what? 0. Right? So summary address of upper 3 network will become what? 10.1.0.0/22. And as you know, 4/22 subnet mask will be what? 250. 4/22 subnet mask will be 255.255.252.0. 255.255.252.0. This time I am going to, let's say, use access control list for the path manipulation. So let me take you on router number 5. Here I am going to use access control list this time. So what I will do, IP access list, after that access list name or extender or extended. So let me use extended permit, sorry, name is, let's say, A, and then permit. What happened? Okay, number 10. Done. After that, here I am going to define the permit statement. Permit, let's say 10.1. You don't, if you don't want to perform the summarization also, you can achieve it. See, in this access control list, I am going to permit this network, and this network only. 3.0. Done. I will use this access control list with route map, list number 10. So route map CCNA permit sequence number, let's say 10, and say match IP address from list number 10 and set AS path prepend 11111. I have add 3 time 111 111 111, right? So for the upper three prefixes, I have prepend the AS number on router number 6. Done. Now I am going to use this route map in BGP. So router BGP 500 and neighbor is 68.1.1.8. Use route map. Name of your route map is CCNA. CCNA direction is out. Done. For the three prefixes. Now for that means for these three prefixes R5 will become best, and for the lower two prefixes I am going to add ES on router number 5. So access list, IP access list standard 10 and permit 10.1.4.0 0.0.255 and permit 10.1.5.0. See, like this also you can classify the traffic. It is very easy. Route map, if you are not comfortable with prefix list, then you can, and you are not good in summarization, then you can configure, you can classify the traffic like this also. Route map CCNA permit 10 and match IP address from which list from list number 10 and set AS prepend 111 111 and 111. Done. Now on router number 8. Okay, clear IP BGP star soft in. Done. So IP route BGP. See, all prefixes are best via router number 5. Okay, let me verify BGP table. So IP BGP. See, for upper three prefix we have add AS path, right? So best path is via router number 5, and this one is also, that means for the lower two it's not working on router number 5. So let me check. I think I have not applied it with BGP, so I need to apply it with BGP router BGP 500 and neighbor. IP address between router 5 and router 8 is 58.1.1.8. Use route map CCNA direction out. Done. Now on router number 8, clear IP BGP star soft in. So IP route BGP. Now all network are reachable via router number 7. So actually from router number 7 it is getting least number of AS. That's why all network is reachable via router number 7 now. So IP BGP. So for some time what I am going to do, I am going to down the neighborship with router number 7. So here what I am going to do, or on router number 5 also you can down the neighborship with router 7. So let me take you on router number 5. Say neighbor 57.1.1.7 and shut down. I have done the neighbor. Okay. Now on router number 8. Clear IP BGP star soft in and show IP route BGP. Now you can see for upper three prefixes till here. Next hop is 68.1.1.6 means router number 6, and for the lower two prefixes next hop is 58.1.1.5 means router number 5. So best path is via router number 5. So this is what load balancing for the traffic which will enter in my ES. So IP BGP, because you can see, and I have not defined the permit statement in route map. That's why router are not getting the other path from the neighbor. So just you need to do one thing, like in real time you will not configure like this because there is not backup path available now. So here you will create one more route map with same name CCNA and say permit higher sequence number 20. In the same way on router number 5 also, route map CCNA permit and higher sequence number 20. Now let me take you on router number 8 and clear IP BGP star soft in and so IP BGP. Now you can see it is getting prefixes from both neighbor, each prefix from both neighbor, but for upper three prefixes best path is via router number 6. So IP route BGP. Yes, best is via router number 5, and for lower prefixes best is via router number 6. So IP route BGP. Done. Now once more I am trying to ping from router number 1 to this IP address to check that it's working or not. This is software problem of software only, guys. It should work. Don't know why it's not working. 192.168.10.1 and source is 10.1.1.1. It should work, but it's not working. But definitely it should work because all IP addresses are reachable with each other. Done. So this was the load balancing for the traffic which will come in my traffic for the outgoing traffic, for the outbound traffic. Done. So till now we had understand the path manipulation by using wait value, by using local preference value, by using ES path value. We understand the path manipulation and load balancing both as well. Now we are going to understand path manipulation by origin code. So first of all, let me remove the configuration from router number 6. I am going to say no route map CCNA, no IP access list number 10 standard 10 and router BGP 500, and let me check recording. Okay, say do so run section BGP. I'm going to remove this command. Say no. Right, let me do same thing on router number 5 also. No route map CCNA, no IP access list standard number 10 and router BGP 500 and do so run section BGP. Say no and let me remove this command. Done. Now to perform path manipulation by origin code, see by default origin code is what I, because I have advertised both prefix through network command, this network also and this network also, right? So that's why on any router you can check origin code is nothing but your I. But if you want to, as you know, if I will talk about here in origin code, origin code, I is more preferable than E, and E is more preferable than question mark. This is your origin code attribute. Done. I is more preferable than E, so E is not using. That means E is more preferable than I. Done. Like on router number 1, so IP route BGP. So these all prefixes is best via router number 5. Just I want to make best via router number 6 with the help of origin code. Now you know best path selection will happen on the basis of origin code. Now see on router number 1 what I will do, I will create one route map and name is CCNA permit, sequence number is 10, and here I am going to say set origin code. Origin, after that which origin you want to add? Incomplete. So see we have only two options, IGP and incomplete over here as well. So let me say incomplete. I have set origin code incomplete in the route map, and if I will apply this route map with neighbor 5, with neighbor router number 5, that means router 1 will receive all 192.168.10.0 prefixes from router number 5 with origin code question mark, and from router number 6 with origin code I. So best path will become what? Via router number 6. Via router number 6. So see now I am going to apply this route map with in BGP. So router BGP 500 and say neighbor, your neighbor is 5.5.5.5, and for this neighbor use route map, name is CCNA and direction is in. So whenever you will receive a prefix from your neighbor 5.5.5, you will use this route map. Getting my point? Okay, done. Now clear IP BGP star soft in, and so IP route BGP. See all prefixes are best via router number 6. The reason is here in so IP BGP. So IP BGP. See it is getting 192.168.10.0 via 5.5.5 with origin code what? Question mark, and with 6.6.6 origin code is I. So as I told you, I is more preferable than question mark. That's why it is best via router number 6. Via router number 6. Again, if you want to perform the load balancing, you can perform load balancing as well with this attribute. Let me remove it. Say no route map CCNA and a router BGP 500, and do so run section BGP. Where is my route map? This one. So need to remove this command. Say no. See what I want, for upper 3 prefixes it should receive traffic from router number 5, and for lower 2 prefixes it should receive traffic from router number 6. So what I will do, for lower 3 or for upper 3 prefixes I will set incomplete origin code with neighbor router number 6. Yes or no? So IP access list standard number 10 permit 192.168.10.0 0.0.255 for neighbor, for this network also 20 for 30. Done. Now route map CCNA permit sequence number 10 and match IP address from list number 10 and set origin incomplete. Done. and need to create one more route map. So route map CCNA permit with higher sequence number, let's say 20. Router BGP 500 and neighbor 6.6.6.6. Neighbor 6.6.6.6. Use route map CCNA and direction in clear IP BGP star soft in. So IP route BGP. See, all prefixes are best via router number 5. So IP BGP. It have add question mark incomplete attribute for all network or for upper 3 network only. Yes, for upper 3 network only. This one, this one, and this one. But you know, for all rest traffic, it is performing best path through a best path on the basis of lower neighbor router ID. So I am going to do what? I am going to add incomplete origin code for lower 2 network with router number 5. So I am going to create one more access list 20 access IP access list standard 20 and permit 192.168.20.0 0.0.255, not 20, sorry, it's 40 and 50. Done. I'm going to create one more route map. CCNP name is, let's say CCNP, match IP address route map CCNP permit 20 and match IP address from list 20 and set origin code incomplete. Done. A route map CCNP permit higher sequence number 20. I'm going to use this route map in BGP with router number 5. Router BGP 500 and neighbor 5.5.5.5. Use route map what? CCNP and direction in clear IP BGP star soft in. So IP route BGP. Still all network is reachable via router number 5. So IP BGP. See, for this network 10.1.1.0 router 5 is sending with I and router 6 is sending with incomplete sign, and for this network router 6 is sending with I and router 5 is sending with. Okay, so what is problem? Let me find it over here. For the two lower network all are sending, means route map is not working. So run section BGP, let's say neighbor 6.6.6 route map CCNA direction in, neighbor 5.5.5 route map CCNP direction in. So route map CCNP, in this route map I have match IP address from list number 10. So IP access list 20 permit this one and this one. Okay, match 00 clear IP BGP star soft in. So IP route BGP. So IP BGP So run section route map. Okay, route map CCNA, then match IP address, then okay, set origin incomplete, route map CCNP, route map CCN uh, NP permit 10, match IP address from list number 10 and incomplete. There is one problem, guys. No route map CCNP. So a route map only CCNA is there. Again, I am going to create the CCNP route map. A route map CCNP permit and no sequence number 10, and after that match IP address from list number 10 and set origin incomplete, exit, clear IP BGP star soft in, so IP route BGP. Now all prefixes is reachable via router number 6, so it's not working fine. So IP BGP, router 5 is forwarding. Okay, one more thing I need to do here, a route map CCNP permit sequence number 20, so IP route BGP. Now you can see upper 3 network is best via router number 5 and lower 2 network is best via router number 6 because of origin code. So IP BGP. See, when I will talk about the upper 3 network, both router is sending through incomplete sign, and these two prefixes router 6 are sending via I sign. So still there is some problem, but we can troubleshoot it, guys. These are very basic things, right? I am not going to waste time over here going to remove this command. This is how you can perform path manipulation as well by using origin code. You definitely you have lots of option to perform path manipulation or load balancing. Very less time we are using the origin code for the path manipulation. Done. So no route map CCNA and CCNP, no IP access list standard 10 and no IP access list standard 20, router BGP 500, do so run section BGP, say no over here, and let me remove which entry. First one is this entry, and no, there is one more entry, this one. Done. I have removed both entry. Now we are going to understand path manipulation by using MAT. As you know, lower MAT is always preferred, and MAT is also used for outgoing path. For outgoing path, we can add metric value on router number 5 for their neighbor. Let's say this is my router number 5. Router 5 is receiving these prefixes, yes or no, with mat what, or we are not using it for incoming traffic. So we will actually add mat value for these prefixes. When router 5 will advertise these prefixes to router number 8. I can set some metric over here. I can set some metric. Let's say best path is via router number 5. So I will set metric over here. Let's say best path is via router number 6. So I can set some metric over here. Right. So whenever we want to perform path manipulation on British Telecom router from my AS, that time only we are using this attribute. Metric attribute. Now on British Telecom router, if you will run command router 8, enable show IP route BGP. See, best path is via router number 5. Done. Best path is via router number 5. But if router 5 will goes down, then best path will become via router number 6. So IP BGP. Done. Prefixes are reachable from both sides. And metric is what? Blank. Blank means it is also like 0. But here you can see for these prefixes, metric is showing you what? 0. And here metric is showing you what? Blank. On ISP and their ISP are running one command actually. Let me tell you about that command. Once I will run that command, router will set the metric of all routes where metric is blank to 4.2 billion. 4.2 billion. So if I will run that command over here, metric over here will become 4.2 billion. Higher billion, maximum metric. And ISP is running this command. Okay, that will consider metric as worst. So let me show you. Sorry. Router BGP. What is the AS number over here? AS number is 100. 100. After that, BGP best path. Put question mark over here. Then MAD. MAD means metric and missing as worst. This command. Treat missing MAD as the least preferred one. Okay. So let me say missing worst. After that, show IP BGP. So blank metric will consider as worst metric. Now you can see. Via router number 5 also and via router number 6 also. Metric is worst. Metric is worst. Now if you will create the route map on router number 5, let me add some metric from router number 5. So let me take you on router 5. Here what I am going to do, I am going to add some metric. Config T, route map. Every time you will create one route map, right? And name of route map is, let's say, MAD, and permit sequence number is 10. Then after that, set metric. Set metric, and let's say metric, I am setting metric what? 10. After that, router BGP 500 and neighbor is 58.1.1.8. Use route map MAD in which direction? In out direction. Done. Now on router number 1, let me run command clear IP BGP star soft in and show IP BGP. Before running this command, let me maximize it. See now. Now metric from router number 5 is 10 and metric from router number 6 is worst. Done. So best path is via router number 5 on the basis of list metric. Right? On the basis of list metric. Like this, if you want to perform load balancing here, we can perform load balancing as well. Right? Let's say for upper 3 prefixes, I want to add metric over here. So what I can do? No route map MAD and I am going to create route map with same name. Could not find the route map with this name. Do so route map. There is no any route map. Okay, I am checking it on router number 8. So here I am going to remove this command as well. No, and no route map mat. Done. IP access list standard 10 permit 192.16, sorry, 10.1.1.0, 10.1.2.0, and 10.1.3.0. Done. For this network, I want to add metric. So route map name is, let's say, CCNA. It is easy for me. Permit 10, match IP address list number 10, and set metric what 10. Router BGP 500, neighbor is 58.1.1.8. use route map CCNA and direction out. Clear IP BGP star soft in. So IP BGP. See, for these three prefixes, router 5 is sending prefix with metric 10, and for lower two prefix I am going to set metric on router number 6. Very easy. Done. For lower two prefixes, router 6 is sending metric 10, and for upper three prefixes, router 5 is sending metric 10. Just you need to run one more command, route map, same route map with higher sequence number with permit statement. That's it. But here we have one problem. Metric router is going to compare metric only for same number of AS. Let me make you understand with example. See, I have router 1, router 5, router 6, and router 8. Here I am running AS number what 500. Here I am running AS what 500. That's why router 8 is performing best path selection on the basis of metric. So metric will compare in case of same AS number only. Let's say here I am going to down this neighborship. Done. So router number 8 will receive this prefix from router number 5, and from router number 7 I will up this neighborship, right? Yes or no? In this scenario, here, okay, best path selection will happen on the basis of AS number, on the basis of AS number, yes or no? But let's say AS number is same from both sides, then router is not going to perform best path selection on the basis of metric. When neighbor AS number is different, then router is not going to check the metric. That time just you need to run one command. If you want to tell your router that even you are receiving prefixes from different neighbor with different metric value, you should compare metric. Then you need to run one command. That command is very simple, and that is the only command if neighbor AS number is different. In that scenario, on router number 8, you will run command router BGP 100 and then BGP best path router, not best path size, sorry, always compare mat. This command you need to run. If neighbors are belongs to different AS, then you need to run this command. Then only router will compare the metric value. Okay, I am not going to perform any practical of this. Now let's understand equal cost load balancing in BGP. So see, on router number 1, so IP BGP or so IP route BGP. Oh, what happened? So IP route BGP. What happened? So route map. Nothing is there. So IP route. So IP route BGP. Oops. On router number 5. So IP route BGP. Here it's fine. On router number 1, it's not showing any route. So IP BGP. Only self-advertised prefix are there. So IP BGP neighbor. So IP BGP summary 5.5.5 6.6.6. Okay, receive prefix is 0. So IP route BGP neighbor 5.5.5.5 and received prefix oh, router are not advertising. What happened? Just I need to reload the router. These are problem of software. Say no. I need to reload this router. Wait. Till then I need to remove the mat configuration also from router number 8, or we can leave enable. So IP route BGP. So IP BGP neighbor summary. Both neighbor is up. So IP route BGP So now again I am receiving these prefix. Done. So see, these prefix is there in the routing table of router 1 via router number 5. But in the BGP table, you are able to see so IP route, so IP BGP. You are able to see there are two path available, and best path election is happening on the basis of lower neighbor router ID. That means uh, IGP cost to reach next hop till this attribute, everything is same. That means we can perform load balancing. As I told you, if till the attribute next hop IP IGP cost to reach next hop is same, then we can perform load balancing. What I am saying, we can perform load balancing if till the attribute IGP cost to reach next hop is same. So how we can perform load balancing? Still we are able to see two paths are there in the BGP table, but in the routing table, so IP route BGP there is only one path. So we need to just run one command, guys. Router BGP 500 and say maximum path 2. Done. After that, so IP route BGP. So IP route BGP. Router is not installing both path, but soon router will install both paths. So IP BGP. You know, I have run command. So maximum path router BGP 500 and maximum path 2. This is for IBGP neighbor. This is for IBGP neighbor. So I am going to say no over here. No, sorry, this is for eBGP neighbor. This is for eBGP neighbor, but my neighbors are IBGP neighbor. Yes or no? Router 5 and router 6 are IBGP neighbor. So we will not run command like this. Maximum path. After that, if you will put question mark here, you can see you can define the number directly for eBGP neighbor, but for IBGP neighbor you have to add this keyword over here, and then it is 2. Now so IP route BGP, you can see it have installed both path in the routing table. And if in the routing table there are two paths, then definitely router will perform what? Load balancing. Now I want to open this path in detail. So IP route 192.168.10.0 255.255.255.0, let's say. See, when I open this path in detail, here I am able to see, not here. Okay, let me run so IP BGP directly. So IP BGP here 5 routing entry for this network non via BGP 100. Yes, metric is distance is this one, metric is 0, tag 10 is typical. Okay, last update is from 6.6.6. It's a packet, fine. Yes, hope is 2. Okay, okay. So IP BGP, here you can see the M symbol, and M means nothing but multi path. Guys, this path is still not best. Still this path is not best via router number 6. Only this path is best. Means router will advertise only best path to their neighbor, not this path. Okay, so most of the people have confusion, and interviewer is asking lots of time this question in interview, that in the routing table router of BGP router have installed two path. In the BGP table we are able to see one path is not valid, but there are M symbol, that is multipath. So tell me, will router advertise both path to their neighbor or not? So no, router advertise only best path to their neighbor. Router will not advertise this path to their neighbor, right? If you want to verify it, you can verify it, but before that let me run one command. So IP BGP 192.168.10.0. Here also you can see which one is best path. 5.5.5, this is best, and this one is oldest. Done. This one is oldest, this one is best. So if I will configure BGP on router number 2, so this will be the iBGP neighborship. Let me configure BGP on router number 2. Let me check that router 1 is advertising both path to 2.2.2 or not. Enable show IP BGP summary. So BGP is not running there. Now let me configure BGP. Router BGP 500 and neighbor 1.1.1.1 whose remote AS is also what, 500. Done. Configuration on router number 2 is done. Now let me take you on router number 1. Here I am going to configure router BGP 500 and neighbor 2.2.2.2. Remote AS is 500. Through OSPF we have reachability between 1.1.1 and 2.2.2. Done. So soon neighborship will come up. So IP BGP summary. This neighbor is idle. Ping 2.2.2.2. Yeah, reachability is there. So IP BGP summary. So TCP brief. Let me verify the neighborship. So IP BGP. So IP BGP summary. Ping 1.1.1.1. Source 2.2.2.2. So TCP connection is there with 5.5.5 and 6.6.6 only. Then what is the problem with this one? Yeah, we need to configure update source. Loopback 1. So on router number 1, say neighbor 2.2.2.2 and update source loopback 1. In the same way on router number 2 also, say neighbor 1.1.1.1 update source loopback 1. So now you can see BGP neighbor is up and show IP BGP. In the BGP table you can see router 1 is advertising only this prefix, the self advertised prefix, which router 1 is advertising, because router 1 will not advertise those prefix which they have received from their iBGP neighbor to the other iBGP neighbor. So here what we need to configure, we need to configure the root reflector, right? So on router number 1, what I am going to say, neighbor 2.2.2.2 route reflector client, route reflector, let's say yes, client. Now if you will check the BGP table of router 2, so IP BGP, router 1 is advertising only network via router number 5 through router number, that means only best network. Okay, so even router have installed both path, two path in their routing table, but it will advertise to their neighbor only those paths which are best. So IP route BGP. Okay, so in BGP table you can see there are two paths, but it is advertising only best path to their neighbor. So IP BGP. Okay, so don't think that if I have configured the maximum hop 2, that means both path have become best path. Still this path is not best path. Done. Now guys, we are going to understand the aggregation in BGP, or you can say summarization in BGP. So see, this is very important. First of all, let me copy this diagram in Paint. Let's say here my scenario is different now. Okay, this is my scenario. Wait. Okay, done. Now guys, try to understand the aggregation or summarization in BGP. First of all, see, router number 8 is advertising these prefixes, right, to router number 8. Let's say router 9 is advertising 1000 prefix, 1000 prefixes in my ES. Hardware configuration of router 5 and router number 6 is fine. These router can maintain thousands of prefixes in their routing table. But router 1, this router cannot maintain thousands of prefixes in their routing table. So again we have problem. What I am saying, suppose R5 and R6 are advertising 100,000 number of prefixes to R1, but if R1 cannot handle thousands of prefixes in their routing table, then we need to perform what? Summarization. We need to perform summarization on router number 5 and on router number 6. Yes or no? Like in IBGP also, when we had lot of prefixes and router cannot handle those prefixes, then we need to perform the summarization in AIGRP, in BGP, like that in raw in BGP also we can perform the summarization. But in BGP we call to summarization is aggregation. Aggregation. Aggregation means also meaning of both summarization and aggregation is same, right? So on router number 5 we can run some command like router BGP 500, after that aggregate address, and then you can define the summary address of this network. Let's say summary address is 192.168. What will be the summary address, by the way? Summary address will be 192.168.0.0 slash, or subnet mask slash will be 18, or you can say 255.255.192.0. This will be the summary address. After that you will say summary only. Summary only. After running this command on router number 5, let's say, router will start advertising one summary network, this network only, instead of advertising these all network to router number 1, right? And router 5 will keep, in EIGRP, as you know, whenever we perform summarization, router are taking one summary route in their routing table with null interface, with null zero interface. Why? Because of loop. So like that, router 5 will also keep one summary address in their routing table. Okay. After that, on router number 6 also we can run the same command. When we will perform the summarization, two extra attribute will add in BGP, right? In the BGP update, router will add two extra attribute. Let me discuss about that attribute. First attribute is that router will add is aggregator. Okay, aggregate this aggregate attribute, and another one is atomic aggregate. router will add these two extra attribute when you will perform aggregation on the router. Guys, aggregate is, it tells who is advertising the summary route. Who is advertising the summary route? Like if router 1 is advertising, router 5 is advertising, so there will be router ID of router 5. Who advertise? You can say who is advertising this attribute. That information will be there inside the aggregate attribute. Sometime interviewer is asking this question, guys, that what is the use of aggregate attribute, and when router will add this attribute in the update message. Okay, and atomic aggregate summary address without ES path. Actually, when we are performing summarization, so there will be summary route information. Definitely yes. In the summary route information, router will not add ES number. Router will not add ES path. You can say ES path by default. Okay, so still we have some problem. Because of this problem can be occur, right? When router 5 will also advertising and router 6 will also advertising, router 1 was for selecting the best path on the basis of ES path, but router is not advertising what? ES. Done. So this time when R5 and R6 it advertising, let's say I have summarized these prefix, right? And router 5 and router 6 is advertising to router number 8. So on router number 5 you will run command, on router number 6 you will run command, and you need to run one more command so that router can start copying the AS number from the prefixes to the summary route, and that command is known as aggregate address. After that, summary address, summary subnet mask, and then you will say summary only AS set. AS set. That's it. So interviewer can ask you sometime that when we need to you need to set AS set in the aggregate, and why. The reason is clear to you. By default, when we perform summarization, routers not add the AS path attribute. Once you will set the AS, then router will copy all AS number from the prefixes. Let's say router 5 have received these all individual prefixes. It have AS number 100 and let's say 200. When it will advertise the summary address, it will advertise without the AS number. But if you will set the AS, if you will run the command aggregate address, after that summary address, summary subnet mask, summary only, and AS set, it will copy these two AS from the individual prefixes from the summary address. Let's say you are summarizing a prefix, and out of the summary prefixes, three prefixes have two AS number 100 and 200, and two individual prefixes have AS number 500, and you have combined, you have summarized the all prefixes, so it will copy all AS path. Okay, so this is, you know, some one concept interviewer is sometime asking question from this topic. So let me take you on configuration part again. Here on router number 5, I am going to summarize the prefix. Now router 1 and router 2 is receiving individual prefixes. Config T. After that, router BGP 500. Aggregate address. What will be the summary address? Summary address will be 192.168.0.0. Subnet mask will be 255.192.0. Done. This is the summary address. After that, 255.192.0. This is summary address, and here if you will put question mark, so here you can see the option summary only. Filter more a specific route from the update, so say summary only. It will not advertise the individual prefix now. Done. Okay. After running this command, show IP route. Show IP route BGP. Are you able to see the summary address and null interface? And who is advertising this router? Because next hop is 0.0.0.0. Now let me take you on router number 1. And here I am going to run command show IP route BGP. See, summary router 5 is advertising only summary network, and these all individual networks router are getting from router number 5. So IP BGP. Router 5 is not advertising individual prefix now. Done. Let me do same thing on router number 6 also, but before that, if you want to check so IP BGP and summary network 192.168.0.0. So here you can see two new attribute. One is atomic aggregate and another one is aggregated by ES 500 and 5.5.5.5 is the router ID of router 5. So here is information of ES number and the routers who is summarizing this prefix. Done. In the same way on router number 6 also I am going to perform the summarization. Config T router BGP 500 aggregate address 192.168.0.0 255.255.192.0 summary only. Okay. On router number 1. So IP route BGP. Now you can see the routing table. There is only 2 route available, right? So both router is advertising prefixes after summarization, right? This is summary route. Okay. Now when router will ping the IP address 192.168.10.1. So match will match will found in this entry, so it will forward it to router 6 also and to router number 5 also. Done. Now question is how we can perform load balancing. Now it's performing equal cost load balancing router 1, but there are some more command here. Here we have concept of actually suppression, suppress map for load balancing. Like how we can achieve load balancing on router number 1 for summary address. Now it is performing the summarization, sorry, what we say, load balancing, but this is different load balancing. What I want, let's say I want for upper 3 network it should forward traffic to router 5, for lower 2 prefixes it should forward traffic to router number 6. So for that type of scenario you have suppress map. So on router number 6 let me run one command. Here I am going to say aggregate, after that aggregate address, then 192.168.0.0 is the summary address, 192.192.192.0. After that summary only, and here you can say set yes. Before running this command, set yes, wait, before running this command, if I will show you on router number 1 the BGP table, so IP BGP. See in the summary network, are you able to see any ES number, ES path? No. So that's why I am going to add the keyword over here, that is set or I think AS set. I've set the AS number. Now on router number 1, clear IP BGP star soft in. So IP BGP. Now you can see when router 6 is advertising the summary prefix, it is adding the AS number. But when router 5 is advertising, it is not adding the AS number. So actually router are copying the AS number from the individual prefixes. So on router number 5 also I am going to say router BGP 500 aggregate 192.168.10 dot sorry 0.0 255.255.192.0 summary only and set AS set this command. Done. After that on router number 1 you can see both router are advertising summary route with AS number. So it have started adding attribute. Done. Now there is some more command on router number 6 where it is aggregate address 192.168.0.0 255.255.255 dot sorry 192.0 summary only AS set and after that suppress map this command. And now if you will put question mark, so see route map for separation, but first we need to define the interesting traffic over here. Guys, if you want to learn these things in detail, you can enroll yourself for my upcoming live training. I am starting a new batch from 1st of June where we are going to discuss these things in very details from the very beginning, right? So layman can also understand these things. Here it is not possible to explain everything through the video because you are not, I don't know you guys are getting me or not. So through live session only I can make you understand these things in detail. Okay, so here I am leaving this topic now. Aggregation, this is very simple topic and hope now it's clear to you. There are some more concept but here we are not going to. Okay, one more thing just I want to show you over here, that if you want to perform the load balancing for upper 3 traffic on lower 2 network, so what you can do here, you can create one prefix list, IP prefix list, and name is, let's say, CCI permit. Okay, and after here I am going to define the upper 2 network, that is 192.168.10.0 sorry 0.0 and slash value will be 19 and equal greater than equal to 24 and less than equal to also 24. Now I am going to use route map again. Route map, name of route map is, let's say, anything, PM permit 10 match IP address from prefix list, and name of prefix list is CCI. Like this you can configure the route map, you can configure the prefix list. In the prefix list we can match the traffic and then we can configure the route map. And here we are going to say a router BGP 500 and aggregate address 192.168.0.0 255.255.192.0 and route map is, here I am going to first say summary only and then AS set, after that suppress map. suppress map. Name of route map is PM. Name of your route map is PM. So that's it. Now router 6 will suppress only those prefixes which will match in the route map. Right? Now on router number 1, if I will take you on router number 1, and here again I will say clear IP BGP star soft in and so IP route BGP. So now you can see the BGP table. For this is the summary address. Summary address is reachable via both, right? But these two individual prefixes are also there. So now if someone will send traffic to 192.168.40.0/24 network, it will match will found in this entry also and in this entry also. But as you know, router is going to use longest match, so it will use this path. So for lower two prefixes, routers will use the best path via router number 6, and for rest traffic it will perform load balancing. Like this, if you want to configure the upper three path via router number 5 also you can configure, right? So summary route will be also there and individual route will be also there. And we have concept of unsuppressed as well, but it will work with neighbor command. Let me show you. On router number 6, if you will run command neighbor 1.1.1.1 and say unsuppressed map PM, name is capital PM, like this, right? We cannot define direction over here. Direction is not required. Done. Now on router number 1, see the BGP routing table of BGP. Router have all individual prefixes via router number 6 and summary route as well via both router. So it will perform load balancing as well. And first of all, when traffic will generate by router, match will found over here in this entry. If match will not found, then only it is going to check the summary route. Okay guys, so this was the concept of aggregation in BGP. Guys, there is one more concept in BGP that is most popular, and that is, let's say here in this topology, see, here I have just configured the route reflector, right? So like when R5 will advertise or say R2 have some prefixes, let's say 20.1.1.0/24. So 20 will advertise it with router number 1, but router 1 will not advertise to router number 5. Here we to configure what? Route reflector. Suppose there is BGP neighborship between all routers, like router 1 have BGP neighborship with 3 also, 5 also, 4 also, 6 also, 2 also. So how many time we need to configure the route reflector? Yes or no? So that is not possible. So that's why we have concept of BGP configuration. BGP configuration. This one. BGP configuration. BGP configuration is concept of sub AS. Like in my AS, you can see here all routers belongs to AS 500. Yes or no? Here we have router 1. This is my physical topology. If I will talk about the logical topology, BGP topology. So my BGP topology is router 1, router 5, router 2 and router 6. We have neighborship like this. This is my BGP table. And we have one BT, let's say British Telecom, this router here, BT router. Right. This is my AS500, AS500. Yes or no? And on BT we are running AS 100. So when router 2 will advertise any prefix or router 1 will advertise any prefix, that prefix router 6 will not get, or router 2 will advertise any prefix, that prefix router 5 will not get it. Yes or no? So here inside my ES, what we can do, we can configure the eBGP. Like here I will configure BGP ES number 1. Here I will configure BGP ES number 5. Here I will configure BGP ES number 2, and here I will configure BGP ES number 3. This is still my single ES 500, but inside the ES 500 we have config sub ES. Yes or no? These are sub ES, and this type of neighbor, there will be some neighbor, one neighborship between router 1 and router 2. There will be one neighbor of IBGP also. Yes or no? Because here also I am running 500, here also I am running 500, so there is one IBGP neighbor, and this BGP neighbor, the neighborship of BGP S number 1 and S 5 is known as config eBGP. This is config eBGP, config eBGP neighbor. Okay, like on router number 2, just I have configured the route reflector client. On router number, where is router number 2? Here it is. If you will check config t, not config t, so run section BGP. Let me verify the command. So see, I have configured what? Update source loopback 1. Okay, I think I have configured it on router number 1. So let me take you on router number 1. So run section BGP. Okay, yes, this command. Neighbor 2.2.2 route reflector client. I am going to remove this command. Say no over here. Router BGP 500 and say no. I have removed the command. Now see router number 2. Where is router 2? Here it is. Router 2 show IP route BGP. Router is not getting 192.168.10 prefixes because there is neighborship between router 1 and router 2 only. There is no neighborship between router 2 and router number 6. Okay, that means whatever prefixes router 1 will receive to their IBGP neighbor, it is not going to advertise to router number 2. Yes or no? This is problem, and here we have to configure, like if we have BGP neighborship with all routers, then we need to configure lots of route reflector. So see, I am going to show you the configuration of configuration concept. So what is configuration? Configuration is concept of sub ES. Within my ES we can create the sub ES. Okay, and that is nothing but the configuration. Okay, so let me take you on router number 1 first. On router number 1, see, the configuration is very simple. On router number 1, I am going to configure BGP ES number 1. On router number 5, I am going to configure BGP ES number 5 with the router ID. Okay, so config T. After that, okay, first of all, what we can do, we can either start configuration from, okay, let's say router BGP 1, S number is 1, BGP is already running, that is BGP 500, so I am going to say no BGP 500, no router BGP 500. I have removed configuration, BGP configuration from here. I am going to say no IP BGP on router number 5 also. Enable config T, say no router BGP 500. Done. And on router number 6 also I am going to say, where is router 6? Here it is. config t, no router BGP 500. I have removed it. Let me remove from router number 2 also. No router BGP 500. Now let's see, from router number 1 I am going to start configuration. So router BGP 1. I have configured BGP 1. See, in my AS I am going to configure eBGP neighborship, right? My main AS is AS 500 and these are my sub AS. After that, BGP configuration, configuration identifier. Configuration identifier is my 500, BGP 500. And now I am going to say BGP configuration and peer. How many peer of router 1 is? Are there are two neighbor, router 5 and router number 2 and router 6 as well. So say peer is, total number of peer is 3. After that, and you know, in case of eBGP only you need to define the peer. After that I am going to say neighbor 5.5.5.5 whose remote AS is 5, let's say. Neighbor 2.2.2.2 whose remote AS is, let's say, 2. After that, neighbor 5.5.5.5. First of all, I am going to show you the configuration between router 1 and router 5. Like this only you can configure all routers, right? We don't have much time now, so that's why I am configuring it very fast. Router, sorry, neighbor 5.5.5.5 remote AS. After that, update source loopback 1, and you need to define one more thing, that is neighbor 5.5.5.5 and eBGP multi-hop. eBGP multi-hop, how many multi-hop is required? 3, let's say. Because like this, from here if it will reach, router 1 will reach from router 4 to router 6 to router 5, then it's need 3 hop. Okay, that's it. Now let me take you on router number 5. Here router BGP AS number, let's say 5, and neighbor is 1.1.1.1. Remote AS is 1. Neighbor 1.1.1.1. Update source loopback 1. After that, neighbor 1.1.1.1 and eBGP multi-hop is 3. Done. Now you can see what problem I did. So 1.1.1 is possibly done. Okay, there was some incorrect configuration, guys. I have corrected. On router number 5, actually I forget to run BGP, I think, configuration identifier 500 command or BGP configuration peer command. Okay, peer means your remote AS. Okay, so like here you can see I have configured on router number 5 configuration peer and router 1 means on router number 1 I am running what AS 1. Okay, so if on router number 2 you are running AS what 2, so BGP configuration neighbor will be 1 and 2, like this. Okay, And on router number 6, here let's say you are running command what? Oh, you are running BGP 6. So your command will be, you can directly run command like BGP configuration peer 1 2, after that 6, like this you can run, or manually wise one by one also you can define. Okay, but now you can see my neighborship is up. So IP BGP neighbor, sorry, so IP BGP summary. Continuously I am speaking from last I think and 3 hours. So then that's why now I need break as well. See guys, 1.1.1 is neighbor done. And one more thing, here you can see BGP identifier is 5.5.5, local AS is what? 5. This one is your sub ES. This one is your sub ES, and your main ES is so IP. So IP protocol, by running this command also you can verify some your local ES number, means sub ES number. After that, whatever command you have run, configuration consist means peer, and automatic summarization is disabled. And the command which we have run here to define, you can see BGP configuration identifier, the 500. This is my actual ES number. This is my actual ES number. Now we have one more concept in BGP, that is BGP community. Guys, always keep in mind BGP community. Most of the time interview is asking question from community as well. So it is an optional transitive attribute, and it is used to perform tagging. Like in IGP protocol we are performing path manipulation with the help of tag number. Through route map we are adding the tag, like that. If you want to add tag with traffic, you can use BGP community. And after that, what benefit you can take? So if you are able to add the tag number, that means through tag you can perform the path manipulation, you can perform the path filtering, right? These advantage you can take from the BGP community. BGP can contain tag information for each and every prefix in its BGP table. Like suppose if a BGP have 1000 prefixes, so for all prefixes it can add tag number, right? Through which attribute? Through BGP community. Community is also an attribute. Here we have some more attribute in BGP community. Let me discuss that. First one is, look, I am explaining as well at the same time. I am writing the attribute as well and explaining as well. Okay, so first of all, it should be very clear to you that what is BGP community. So as I told you, community is an attribute which is used to perform the tagging. Okay, now community, there are two types of community. First one is predefined community. Predefined community, and second one is on community, OW and on community. If I will talk about the predefined community, so we have some types of predefined community. Let me say over here A, and this one is your B. Done. Now if I will talk about the predefined community, so we have no export, second one is no advertise, third one is internet, and fourth one is local AS. Local AS. These are predefined community. Now if I will talk about the no export, so let me make you familiar with this with one diagram. If a router receive prefix with no export attribute, always keep in mind like this only, or you can make a note. Wait. So see, no export means if a router receive a prefix with no export community attribute on, then that router will advertise that prefix to their IBGP neighbor only. What I am saying, let's say I have one router, router 2, router 3. Here I am running AS100, here also I am running AS100, here I am running AS200. So if this router will receive a update with which community, with no export community, so it will advertise that to their IBGP neighbor only, not to their eBGP neighbor. So you know, sometime in real time it is my requirement can be like a router should advertise prefixes to their IBGP neighbor only, but they should not advertise to their eBGP neighbor. So in those scenario we use this attribute. Okay, like in my topology, let me show you my topology as well. In my topology, R5 is receive some prefix from a Sprint US, from here R5 done. And what I want that R5 should advertise those prefixes which you are receiving from Sprint US to your IBGP neighbor only, right? So router 5 should not advertise it to this router, to British Telecom router. It should advertise it to R1 and to R6 only. So here we can use that attribute. Done. Hope it is clear, guys. After that, next attribute is your no advertised. So if a router receive prefix with no advertised community attribute, then router will advertise that to their IBGP as well as eBGP neighbor, right? So if you want to share, you know, to both neighbor, then you can use this attribute, right? After that, internet, it is by default attribute, it is by default community attribute. This one is internet. I'm talking about internet. So this attribute will advertise only IBGP neighbor. This attribute will advertise to both neighbor. Sorry, it will not advertise to their IBGP as well as to their eBGP neighbor. Okay, after that we will talk about, if I will talk about the internet, so internet is by default attribute, and local AS is used in, just we have discussed the configuration. So local AS is used in case of configuration, and in next video somewhere I will show you the practical of the community attribute as well, guys. Now today we have very long video length, so we are not going to discuss anything else today in this video. Thanks for watching. If you are still watching and if you have learned something from this video, guys, please hit on like button. And last one is one more thing on attribute. Sorry, I forget. On attribute, so this attribute is an 32 bits decimal value like EIGRP or OSPF tag number. So as I told you, we are using community attribute for the tagging. So on attribute can be used 32 bits decimal number for the tagging. So if it is an 32 bits value, so you can calculate the range, right? By using tag we can perform the path manipulation and route filtering, and many more things are there that we can achieve through the tag number. Okay, so that's all, guys. That's all for today. We will meet soon in next video. Till then, stay safe. Bye.